Hello YouTube. Today we're going to talk about how to implement a basic queue structure with an integer array. Queues are a bit different from stacks in that they always return the element that was added to the queue first, whereas stacks always return the newest element added to the stacks. Now, to visualize how queue works, we can imagine a cash register in a convenience store. The first one to get in line gets out of the store first, and this is the same for all values inside a queue. The first one that gets added would be the first one to get out, and the last value to get added would be the last one to get out. To start this off, we first need to create our instance variables. The size variable will track the number of elements present in the array or the queue. The first variable points to the index of the first element added to the array, and the last variable points to the last element. The index of the last element added to the array. And the integer array q here will be the main body for our queue. And we'll start by creating the constructor. We first initialize the first and last variables to -1 and size to 0. And then we initialize the array, the queue, to a new integer array of size init size. And for the isFull method, we simply return the statement size double equals to q dot length to check whether the queue is full or not. And return size double equals q dot length. And the isEmpty method actually follows a similar logic. You simply return size double equals to 0 to check if there's any element still left inside the queue. And moving on to NQ and DQ, these are essentially what the methods that make queues unique and different from arrays or stacks and other data structures. So what we do here is essentially, so first of all, we need to be conscious of the current size of the queue. So we will have to, so for NQ, we'll have to check if the queue is already full or not. If it's full, we simply return or output a warning message to the console. The queue is already full. Oh, if it's not the case, and suppose now that we're enqueuing our very first element to our queue, so that would be size double equals to 0. That is, we currently do not have any element inside the queue. What we do is we increment both first and last, and of course size double equals to size, to indicate that we are adding one element to the queue right now, and at last we do queue first equals to the value we're going to pass in through the enqueue method. And if this is not the case, that suppose that we already have elements inside the queue and the queue is not empty, we would do else. And in this case, we simply increment the last, because suppose we already have elements inside the queues. The element that we are going to enqueue right now will never be the first element inside the queue. So we only increment the last variable, and of course the size variable, to indicate that we are adding another element to the queue. Then queue last equals to value. And voila, there we go. That would be the enqueue method. For DQ, it's slightly different, but the logic still holds. First of all, we need to be very conscious of the current size of the queue. So if it is already empty, what we're going to do is we're going to output a console message. The queue is already empty. Now, if this is not the case, and suppose we only have one element left inside the stack, inside the queue, we'll check for if size equals to 1, what we do is, oh, actually, first of all, almost forgot. First of all, we need a variable, a temporary variable that's going to contain the value that we're going to return. Because if we are going to remove the first element and return at the same time, we need a temporary storage. So that will be temp equals to 0. Actually, no, q first. So essentially, we are going to make temporary equal to whatever value that is currently sitting on the first index of the queue. And suppose we only have one element inside the queue, we want to reset all the first. We want to reset all our index variables, the first and last, both to -1, and of course we decrement the size so that it's going to be 0 in this case. And at last we return temporary, which is this value over here. And suppose these are not the case. In this case, we simply increment the first because we've essentially, the logic here is that we've already removed this element from the queue, hence the name dq. And we decrement the size because we're removing one element from the queue, even though we're not physically removing it from the array, but still. And then we return temporary. Oh, apparently it's not happy, so we'll have to return, let's see, if it's empty, let's just return integer dot minimum value. dq, and the peek method is essentially dq without the removing of the element from the array. So we simply return the value that is on the first index. And then toString is just, it essentially returns a string representation of our queue. And with all that in place, with all the values and methods in place, we can experiment with our basic queue structures. And so in this main method over here, we're going to first create a queue with the size 10. And then we're going to fill in this entire queue with random numbers ranging from 0 to 1000. And then we're going to print out the queue. And then we're going to enqueue a value. And in this case, suppose that we did nothing wrong in our previous steps. It's going to, because now we already have 10 values inside the queue, it's going to return the error message that the queue is already full. And then after the enqueue, we dequeue. We dequeue if we've done everything correctly. Once we output the string representation of our current queue, we'll notice that one element would be missing, and the same stays true for these two statements. Then let's run the main method. And voila. So this would be our original array, the original queue. So 672, 789, 42, 26, 19, blah, blah, blah. And then the queue is already full because we already have 10 elements, and that is the maximum capacity of the queue that we created. So therefore it returns the queue is already full. And then we dequeue and then we find this, and then we get this queue, 789, 426. Everything stays the same apart from 672, which is missing from here. And we can see that we have 9 elements instead of the original 10. And then we dequeue again, we find that 789 is no longer within the queue, and it's gone, it's been removed, so that we're left with 8 elements inside the queue. And that is all we're going to be covering today, and thank you for watching.